Now let's look into data persistence or persistent data, which is a day-to-day challenge in dealing with. So, so the aim here is to keep the data within the container in spite of containers are in spite of the container was killed and removed. So containers are generally known for its volatile nature. That's because containers are disposable. The way you make any change in a container is always through the image. So if you want to add a package or a configuration file or any serious change you want to do in the container, you don't log in and make changes. That's because they are disposable. So we delete them and we create an updated container from an updated image, and for that reason they are called as volatile. So if we store any data in the container and if we have to replace it during upgrades, rolling upgrades, it's going to remove the container and create a new container. So when it removes the container, all data will be also gone with it. That is the problem here. So now how to solve this challenge? So that's the reason I say a Docker challenge, day-to-day Docker challenge. So how to solve this challenge? That is using persistent, how to keep the data persistence, how to keep the data persistent. So let's take one example. What if you have a container that is stateful like MySQL that needs a database? It stores the databases and reads from the database. If you happen to replace that container, all data will also be gone. All data will also be gone. So what will you do? What if this happens? What will you do? So you have to solve this issue. So how can we solve that issue? That we are going to see in this session. So as you develop software with Docker, you will also discover you have various needs that arise. You may grapple with running graphical user interfaces from a container, running into confusion around the Docker file, build cache, so want to manipulate your containers directly while in use. Uh, so wonder about the lineage of your image, want to reference data from an external source and so on. So here so I will take you through techniques that show you how to handle these challenge, how to handle this challenge and concerns that may arise. So think of it as a Docker toolbox here. Because the persistent data, the volumes or the data that to be stored permanently, this is a challenge. So that's why we have to deal with it. So the Docker only comes up with different solutions. We are gonna discuss various solutions, not one, 4 to 5 solutions I'm gonna provide it to you. So first one, will begin with volumes. Containers are a powerful concept, but sometimes not everything you want to access is ready to be encapsulated. You may have a reference Oracle database stored on a large cluster that you want to connect for testing. Or maybe you have a large legacy server already set up with binaries they can't easily be reproduced. When you begin working with Docker, most of the things you will want to access will likely be data and programs external to your container. We will so I will take you from the straightforward mounting of files from your host to more sophisticated container patterns, so the data container and dev tool containers. Much of the power of containers comes from the fact that they encapsulate as much of the state of the environment file systems as is useful. So sometimes, though, you don't want to put files into a container, so you might have some large files that you want to share across containers or manage separately. So the classic example is the large centralized database that you want your container to access, but you also want other clients to access alongside your newfangled containers. So the solution for this is Docker's mechanism for managing files outside the lifecycle of the container is the solution is volumes. Although this goes against the philosophy of containers being deployed anywhere, you won't be able to deploy your database dependent container where there is no compatible database available to mount. So it's a useful feature for real world Docker use. So let's take one example here. So the problem here is you want to access files on the host from within a container. So, and solution is we are going to use Docker's volume flag to access host files from within the container. So to make data persistent, we have few options. I will take sticky note. Out of which persistent the first one is volumes mount and second one is bind mount. So the volume mount is the best case example for to access files on the host from within a container. So if a container wants to access some files from the host, in that case volumes will be better. For databases, bind mounts would be better because you can attach whatever data that you want to that you want your container to be accessed from inside your host, that can be attached directly, put in volumes, and that can be used by the host, used by the container. So this is a first case, volumes mount. That is that case we are looking on the screen now. So for that we need to use volumes flag to access the host files, and this is how it looks. For this is only for volume mount. Of course this is for database. So let's make it graphical now. So now let's look into this volume case. If you see, you have a container, on the other side you have MySQL process which is running. Now this is where db tables. So this is the directory inside the host machine. Now you want to connect, see, the where db table directory sits on the host file system, and you want to connect this with the where data one directory which is running inside the container. So here the container running on the host maps the where db tables data which is inside the host machine with the /where data in the container. So that's what a mapping, that's what we call that's how we make a data persistent. Now what type it is, that we will see in examples. And here you will see the MySQL process, and a MySQL process affects data on the same directory.